Good morning, dear students. Students, we are doing chapter 3-dimensional geometry. And so students, let's start with exercise 11.2, question number 12. Find the values of P so that the lines 1 minus x over 3 is equals to 7y minus 14 over 2p is equals to z minus 3 over 2 and 7 minus 7x over 3p is equals to y minus 5 over 1 is equals to 6 minus z over 5 are at right angles. Students, here we have the two equations that are in the Cartesian form, and we need to find the value of P so that these lines are at right angles. First of all, students, you should write the Cartesian equation in the proper form, that is the x minus x1 over a1 is equals to y minus y1 over b1 is equals to z minus z over c1. If you compare this equation to the given equation, then it is not in the form of x minus x1. So students, for that first make in the Cartesian form proper. So here we have a condition that if two lines are at right angles, then a1 a2 plus b1 b2 plus c1 c2 must be is equals to 0. So students, by using this one, we first find the value of x1 y1 z1, x2 y2 z2. Okay students, here first take out common minus 1 from here, we get x minus 1 over minus 3, and here coefficient of y is 7, but here coefficient of y must be 1. So by taking out 7 common from the numerator, we get y minus 2, and in the denominator we can write 2p over 7. So, and here z minus 3 over 2 is in proper Cartesian form. So here by comparing this one, we get x1 y1 z1 as 1 2 3 and a1 b1 c1 are minus 3p 2p over 7 and c1 is 2. So students, by using the same process, we will convert 7 minus 7x over 3p, y minus 5 over 1 is equals to 6 minus z over 5. On comparing this with Cartesian equation, again we calculate the x2 y2 z2 and a2 b2 c2. So students, here the coefficient of x is minus 7. By dividing the minus 7 on the numerator and denominator, we get in the denominator minus 3p over 7. In the same way, y minus 5 over 1 is correct, and here 6 minus z over 5, coefficient of z is minus 1. By dividing the numerator and denominator by minus 1, we get in the denominator minus 5. So here we have a2 b2 c2 is minus 3p over 7, b2 is 1, c2 is minus 5. Since the lines are perpendicular, so a1 a2 plus b1 b2 plus c1 c2 is equals to 0. By putting the values, we get 9p over 7 plus 2p over 7 minus 10 is equals to 0. This is very simple, and student, this question is very important for CBSE point of view. So students, in this way we have completed this question. Here the value of P is 70 over 11. Next we have question number 14. Find the shortest distance between the lines. Here we have the two lines in the vector form, and we need to find the shortest distance between these two lines. So students, for that you have to commit to memory the formula of the shortest distance. So here the formula is a2 minus a1 dot b1 cross b2 over magnitude of b1 cross b2. Here a2 and a1 are the position vector and b1 b2 are the direction of the given vector, given line. So here on comparing, we get a1 is I plus 2j plus k cap and b1 is I minus j plus k. In the same way, on comparing the second line with r is equals to a2 vector plus mu b2 vector, we get a2 vector is the 2I minus j minus k, and this is the b2 vector. So students, here we need to find first a2 minus a1. On subtracting these a2 minus a1, we get I minus 3j minus 2k. Calculation is very simple. And in the next b1 vector, b2 vector, we need to calculate the cross product of these two vectors. What is cross product? Friends, you have to simple solve the determinant by putting the ijk in the first column, in the first row, and by writing the scalar components of ijk in the second row and third row. So here we have 1 minus 1 1 in the second row and 2 1 2 in the third row. So by expanding this we get minus 3i minus 0j plus 3k. So in the denominator in the formula we have magnitude of b1 cross b2. So how to calculate the b1 cross b2? Here we need to find the magnitude. So for that, squaring the scalar components and adding them, and by taking the square root. In this way we get square of minus 3 plus square of 0 plus square of 3. We get under root 18 and that is equals to 3 under root 2. So students, by using all the values in the formula, shortest distance a2 minus a1 dot b1 cross b2 over magnitude of b1 cross b2. We need to calculate the dot product of both. So by dot product we know that I dot I is equals to 1, j dot j is equals to 1, k dot k is equals to 1. And if we do the dot product with I dot j, we get 0 value. So students, by using the concepts we get the minus 9, and by putting the value the shortest distance is 3 under root 2 over 2. Students, this type of questions has come already in the CBSE 2019. So students, this is very important questions. Next, here we have the same question. This question is in the Cartesian form. So students, you can do first convert the Cartesian form in the vector form. After that you can use the same method a2 minus a1 dot b1 cross b2 over magnitude of b1 cross b2. Here first convert this one. I am sharing you the method how to convert a Cartesian equation in the vector form. Here we have this equation. So we can write this equation as r vector is equals to, what is a vector? A vector is minus I minus j minus k, okay, plus lambda is the scalar, and here we have the direction 7 minus 6 1. So we will write 7 I cap minus 6 j cap plus k cap, okay. So this is the vector form of the line. In the same way you can convert the second line in the vector form by solving these two equations. By using the method of shortest distance you can solve this question, and here I am sharing you the Cartesian form. You can also do by this method, but vector form is very easy. So students, here we have the next question. Find the shortest distance between the lines whose vector equations are given. Student, this is also the same formula. First you have to observe what is a vector and b vector. After that, observing a1 a2 b1 b2, you can use the formula of shortest distance. This is similar question. Try to solve this question your own, okay. Next we have question number 17. Find the shortest distance between the lines whose vector equations are given. Students, this is the same question, but here is difference that the scalar components are in the form of s and t. So don't afraid of this, just go with the working rule. Shortest distance between the lines of the vector form is a2 minus a1 dot b1 cross b2 over magnitude of b1 cross b2. So here we have the r vector. Here the component of I cap is 1 minus t, component of j cap is t minus 2, component of k cap is 3 minus 2t. And here students, next we have r vector. Again, component of I cap is s plus 1, component of j cap is 2s minus 1, component of k cap is minus 2s plus 1. So students, here on comparing these two we get the a vector, b1 vector, a2 vector, b2 vector. Here a1 vector is I minus 2j plus 3k, and b1 vector is minus I plus j minus 2k, because here t is common. Students, in the previous questions we have used mu lambda as a scalar. So here we have t and s in the given equations. So first take the common t and s common in the second line. In this way we get the first one is the a1 vector, and with t we have the b1 vector. In the same way we have this is the a2 vector, and with s is the b2 vector. So students, here first calculate the a2 minus a1 by subtracting these two, I minus j minus k minus in the bracket I minus 2j plus 3k. We get on solving this 0i plus j minus 4k. And next is the b1 cross b2 vector. By writing down the ijk in the first row and the scalar components of b vector minus 1, 1, minus 2 in the second row, 1, 2, minus 2 in the third row. By expanding this one, by using the determinant, how to expand, we get 2i minus 4j minus 3k. So students, in this way we have calculated the b1 cross b2. Now it's time to calculate its magnitude. So students, by taking the scalar components of ijk 2 minus 4 minus 3 and adding all these scalar components by squaring and taking the root, we get under 29. And after that, in the formula we have dot product of b1 cross b2 and a2 minus a1. So students, by doing the dot product, we have 2i into 0i, we get 0, minus 4j plus j. By multiplying this, we get minus 4, multiplying minus 3k with minus 4k, we get plus 12. So in this way we get the answer 8. So here, by using the values which we have calculated in the formula, we get answer 8 over under root 29. Therefore, the shortest distance between the given two lines is 8 over under root 29. So students, in this way today session we have completed the shortest distance between two lines and finding the value of a p when the given lines are at right angle. Students, both the questions are very important according to CBSE point of view. So students, if you like my video, then please like, share and subscribe. Thank you for watching the complete video.